All right, so we're on a new unit. Good thing this is the last unit. I did split it into two parts. So this first part is about Earth and the Moon. Second part is about the solar system. Um, all right, so today we are looking at round Earth. The Earth is round. Um, so back in the day, way, long time ago, proving the Earth was flat was really easy, especially like in the Middle Ages because they didn't move around very much when way back when because they didn't have cars and planes and stuff like that. All they had were their two legs and horses or cows or donkeys or some camels, stuff like that. So most people did not go much farther than like 5, 10 miles from where they originally live. Um, so even if they stood on a mountain and looked out, their world was flat. All they saw was flat land. So proving it at that point in time to be round took some creativity. But there were clues. There were two clues, two huge clues that the earth was round. The first clue in the sky, I'd say like days like today, but like seriously, you can't see it. The first clue would be that the sun is round. Yes, you can't really look at the sun, but say you were to glance at the sun and then look away, you'd have that circle in your eye, so you know that the sun is round. The other one at night, which will be coming relatively soon, is the moon. The moon is round. So you have both the sun and the moon is round. So if you put two and two together, kind of like a puzzle piece, you would kind of think that, yeah, maybe the earth was round. Well, so there was this dude called Aristotle. From 384 to 322 BC, famous Greek philosopher. You may have heard of him. He's a scientist also. He was a mentor to the famous conqueror Alexander the Great. And if you know from history, Alexander went through and conquered a whole bunch of lands, civilizations, and acquired their technology. He tried to conquer the world. One of the things, one of the pieces of technology that he acquired, which in a way got transferred to Aristotle, was a field telescope. That's, the little tiny ones where you can just look out and see. Well, this field telescope helped Aristotle. How did it help him? Well, he would stand on a dock and he'd look at the ships going to and from, and he'd notice, hey, well, if the earth was flat, wouldn't a ship sailing away, yes, it would get smaller in scale, but wouldn't it stay flat? Wouldn't it just keep going straight? Instead, what he saw was they would get smaller, and as they went smaller, they started to disappear over the side. That was his first clue, his first little bit of proof that, hey, the earth isn't flat anymore like we thought. It's round. So about 50 years later-ish, there's this guy called Aristophanes. He's a Greek scientist, astronomer, mathematician, who was the chief librarian at the Great Library of Alexandria in Egypt. So Aristophanes, just like Aristotle, like 50 years before, knew that the earth was round, but he decided he was going to prove it using math, figuring out the circumference of the earth. Well, remember, way back when they didn't have airplanes and stuff like that. They didn't have space stations. They didn't have any of that. So how was he going to figure out the circumference of Earth? Well, the circumference or any circle, you'd have to know the distance all the way around the Earth. At that point in time, without much technology, the only way they could really figure it out is if somebody had 10-foot section and they kept just switching back and forth that rope. Kind of can't do that, right? Because there's water in the way. So what he figured out is he used math, basic math, a few facts without leaving the comfort of his home city of Alexandria. And he noticed, because he had buddies elsewhere, in different cities, but he noticed in Alexandria there was this large stone called an obelisk. An obelisk looks like this. Just, you've seen a couple of these, hopefully, in pictures. It's just a long peak standing up. And that helped him out because on June 21st, the first day of summer, hint, hint, you might need to know this a little bit later. Aristophanes measured the angle of a shadow cast by that obelisk. So he would measure this right here, and he noticed it was about 7.2 degrees. He had some buddies down in Syene, a ways away, that noticed on that same date, when they looked down a well, when they were going to get water, they could see the sun directly in that well. Well, what that means is the sun was directly overhead at that point in time. So Aristophanes took these two numbers. He's like, okay, so if it's directly up and down, I can make an angle. Yes, we're coming into a little bit of math involved. He can take the angle from Syene and the angle that he got at Alexandria to figure out, the circumference, 360 around. So, all right, let's go on a little bit with the notes. So for that to happen, he knew the sun had to be directly overhead in Syene. All he had to do was figure out the distance between the two cities to figure out the circumference. He did this by measuring the distance that it took a camel to reach one of the cities. And I figured it out to be 5,000 stadia, which in our terms and kilometers wise, it's 928 kilometers. So he just plugged in those numbers to get the circumference. This is the angle at which he knows. So he took from Syene to Alexandria. He knows that Alexandria is 7.2, using Syene as his focus point because sun's directly overhead, 90 degrees up. Knows a circle's 360 degrees. He found the distance between the cities, and that'll lead to the circumference. All right, so let's plug it in. So this is how it would look. And then if I do the math, if I do a little bit of algebra, you got 928 times 360 degrees, which gives you 46,400 kilometers. All right, well, the circumference of the actual Earth, we know this now. It was measured. It can be measured. What is it? Okay, get this. It's 40,075 kilometers. Look at how close that is. That's pretty darn close for not having all the technology we have now. What kind of screwed it up, though, was probably the fact that this is at the equator. It's 40,008 kilometers at the poles. Well, what's so special about that? It means that the Earth is slightly flat at the poles and slightly bulges at the equator. That's something he didn't count on. So the true shape, if you remember way back in the beginning, it's called an oblate spheroid. All right. So this is round Earth. Watch the Edpuzzle and Zoom with me. If you have any questions, Zoom with me once a week just to check in, say hi. Besides that, I hope you guys have a great day.